Okay, we are studying about the quantum numbers. These quantum numbers are very important for this class 11, and this is completely new topic. That's why you should understand about this topic. So in last class we have studied about the principal quantum number, which is represented by the symbol n, and this quantum number mainly represent the main energy cells. I mean, it represents the cells present in an atom. N value may be 1, maybe 2, maybe 3, except 0. N value start from 1. If n value is 1, it represents first cell. For example, this is your nucleus. First cell, second cell, third cell, fourth cell, like this. For first cell, n value is 1. For second cell, n value 2. Third cell, n value 3. Fourth cell, n value 4. So like this way, this n value represent different cells. First cell is also called K cell, second cell L, third cell M, fourth cell is also called N. You know the name, already you have got. So n equal 1 means it represent K cell, n equal 2 means it represent L cell, n equal 3 will represent M cell, like that. And you will get some another informations also from this quantum number. The information, sir, I will tell you, it gives the information about the size of the atom. How it gives the information about the size? Suppose there is an atom which contain up to n equal 4 state. That means it contain 4 cells. And there is an atom which contain up to n equal 3 state. I mean, it has 3 cells. You know, as the cell number going on increasing, the size of the atom also going on increasing. So if you know the value of n for an atom, then you will get the idea about the size of the atom. So this quantum number also gives the information about the size of the atom. Second information, it gives the average distance from the nucleus to the outermost cell. So if an atom contains 4 cells, then you will get the idea about the distance from the nucleus to the valence cell, I mean to the outermost cell. That also information you will get from this quantum number. And another important information you will get from this quantum number, if you know the value of n, you can find out how many electrons, maximum number of electrons may be present in first cell, second cell, third cell or fourth cell. There is a formula, the formula is 2n square. By doing this, you can find out maximum number of electrons present in a cell. For example, for the first cell, n value is 1. So when you put n value 1, you will get 2. That means first cell contain maximum 2 electron. For the second cell, n value is 2. I mean 2 into 2 square. That means you will get 8 electrons, and that's why second cell contain maximum 8 electron. For the third cell, n value is 3. That means 2 into 3 square. You will get 18 electrons, and that's why third cell contain maximum 18 electrons. So based on this n value, you can find out the maximum number of electrons present in a cell, and that is why first cell contain maximum 2, second cell contain maximum 8, third cell contain maximum 18, fourth cell contain maximum 32 electrons. So these are the informations which you will get from the principal quantum number. Now we will move to second quantum number, which is called azimuthal or angular momentum quantum number. This is number 2, azimuthal or angular momentum quantum number, and it is represented by the symbol L. Azimuthal or angular momentum quantum number. Now what is this quantum number, and this quantum number represent what? So as you have got in Bohr's theory, atom can show some spectrum, and they show mainly the line spectrum. When an electron coming from the higher energy state to lower energy state, then you can see some line spectrum. Already you have got in Bohr's theory. But Bohr explained about the hydrogen spectrum only. As you know, hydrogen contain only one electron. But when you consider the multi-electron atoms, I mean those atoms which contain more than one electron, then it is found that although the electron is coming from fourth cell to first cell like this, you can see the line, but actually this line contain number of fine lines. I mean number of lines are present inside it. To explain this presence of fine lines, electron present in any cell of a multi-electron atom, they do not have same energy. I mean, suppose this fourth cell contain 4 electrons, although it contains 4 electrons, although they are present in the same cell, they do not have the similar energy, they contain different energy, and due to different energy, you will get different lines, and these electrons for a multi-electron atom, they move along different path, and that is why they have different angular momentum. So from this concept, it is found that although it is a main cell, this cell contain number of subcells. These are called subcell. I mean inside the cell, some subcells are present, and they have different in their energy. That is why when the electrons coming from higher cell to lower cell of a multi-electron atom, you will get number of lines, and every lines contain different amount of energy. So from this concept, the concept of subcell come. I mean inside the cell, this is your main cell. Inside the main cell, number of subcells are present. So this quantum number, this angular momentum quantum number represent about the subcells present in an atom. I mean within the cell, how many subcells are present, you can find out from this quantum number. First cell contain how many subcell, second cell contain how many subcell, third cell contain how many subcell, you can find out from this quantum number. So this quantum number represent what? This quantum number represent about the subcells present in an atom. So this is completely new concept. In class 9-10 you have got about the idea of cells, but yes, cells are present, main cells are present, but inside the cell some smaller cells are present which are called subcell, and the subcell contain the electrons, and they have different energies although they are present in the same cell. So to explain this, it is found that the spectrum of elements, contain not only the main lines, but there are fine lines, also present. To explain the presence of fine lines, comma, the electrons present in a multi-electron atom. Multi-electron atom means the atom which contain more than one electron. In a multi-electron atom, do not have same energy, and this is because they move along different path. So this is because they move along different path and have different angular momentum. So it is found that the spectrum of elements contain not only the main lines but there are fine lines also present, and to explain the presence of fine line, the electrons present in a multi-electron atom, they do not have same energy, and this is because they move along different path and they have different angular momentum.